All right, this is the at school homework for 3.1 exponential functions and graphs. Got page 206, 25 to 47 odds to do. I'm going to do some of these with you. So this first problem says use the one-to-one property. This one also says one-to-one. Now when you do an exponential function, y equals a to the x, this a is called the base, and this x is called the exponent or power, and a one-to-one function means you want the base to be the same. So if I do number 26, what I'm supposed to change is, that's 64. I need to break 64 down, so the 64 is going to be 2 to a power. So 64 is 8 times 8, and 8 is 2 times 4, and 4 is 2 times 2. This 8 is also 2 times 4, and this 4 is also 2 times 2. So that gives me 1, 2, 3, 4, 5, 6, 2. So what that means is 2 to the x minus 2 equals 2 to the 6th power. So when you get these 2's the same, in order for them to be equal, that means the exponent here has to equal the exponent there. And now you add 2 over, and x equals 8 is your solution to number 26. Okay, this next part wants transformations, and these are just like the transformations we did before. I'm going to do this one right here. So what's changed from this to this is there's a negative in front of the parentheses, in front of the number, the base. So if you remember, that reflects across the x-axis, across or over. I'm going to say over because it's less writing. And then there's a negative in front of the x, and that reflects across or over the y-axis. Now, if I did this problem, this negative would reflect across the x-axis. This 0.3 is less than 1, so this is going to be a vertical shrink by times 0.3, and then this plus 5 out here would be a vertical shift up 5 units. So you need to do 29 and 31 just like we did before. This next exercise is doing the function on a calculator to get the answer, and now we're going to be using E. E is known as Euler's number. Now it looks like Euler, but it is actually pronounced Euler. So this is Euler's number. He's a guy that did a bunch of tests and statistics on plant life, animal life, and all that. And E is known as a natural number. It's kind of the way that things in nature reproduce. So we are going to do problem 34 together. I'm going to get this screen up here so you can see my calculator, but I'm going to shrink this up a little bit. I hope. Let me see if I can move this down to shrink it up. Well, it went completely away. I don't want to go all the way away. Here we go. Back to my main screen here. It sure did. So I'm going to move this thing over here. And I'm going to do this problem over here, number 34. So I'm going to type in 1.5. And now E is to the left of 4. There's an ln button. That's a natural log, but E is in blue. So you have to hit second ln, which is the E button. And then it says we have E to the x divided by 2. And it says we're going to plug 240 in. So we're going to put 240 and hit divided by 2 up there in the exponent. So we got 1.5 e to the 240, and we hit enter. And we're going to round that to 3 places, so that's 1.956. So that's going to be, for number 34, and I should probably write the way it should be. It should be f of 240, because I plugged 240 in for x, and that rounded to 1.956. 1.956. Now we're going to come up here and it says use a graphing utility to construct this. So we're going to do this one right here, and I'm going to get my calculator back out here, and I'm going to move it to where I can see that number. So I want to graph it, so I'm going to hit y equals, and I'm going to type in 2, and then I have to hit second ln again. Ln's down there by the 4. And I've got negative 1.5, so I hit negative, which is under the 3, 1.5, and x is by the alpha. Okay, and then I'm going to hit graph. So So I hit graph, and here comes my graph. So there's the graph. So if you look at that graph, what happened to it, the negative flipped it over the y-axis, and the 1.5 was a vertical stretch. And the 2 is, I'm sorry, the 2 is a vertical stretch times 2, and the 1.5 is actually a horizontal shrink by 1.5. So anyway, we're going to take this, and it said you want ordered pairs. So if I hit second graph, that's going to give me the ordered pairs. So there's our ordered pairs that go together. Now, I hope you see this number's way too big. So we're going to come down here closer to these numbers here. So -2 is clear up at 40. -1's at 8.9. So you're just going to take those numbers and plug those in. And I can still see my calculator. So -1 was up here at like almost to 9. We're going to call that 9. It was like right below that. And then 0 gave me out a 2. So down here, I would go up to 2 and put a 0 there. And again, this is still the horizontal asymptote is still the x-axis, but this one is decreasing. So that's how you graph those, and that's where you find the table. This also says graph using an exponential function, using a graphing utility. So this is actually the same thing, okay? And then we go back to 1-to-1. That's the same as this 1-to-1, which means we want the bases to be the same. And if you look, all these bases are E. So I'm going to do 48 with you. And in order for those bases, both these to be equal, the exponents have to be the same, which means you just drop off the E's and say the exponent x squared plus 6 has to equal 5x. And then this is going to be just like Algebra 1, it's a quadratic because of x squared, so you need to get this equal to 0. So we have to subtract the 5x over, and we got the plus 6 equals 0. And then we're supposed to make a t-chart, and we take 1 times 6 and get 6, and we need -5 here. So factors of 6, that means they multiply together to be 6, would be -2 times -3 is a positive. And this adds up to -5. Now, some people would have said -6 and 1. Well, that does equal -5. The problem is when you multiply these together, they don't give you +6. So then this factors to x minus 2 and x minus 3. And you set each of those equal to 0 and solve. And you get the two answers that will work. You get x equals 2. And you get x equals 3. Now you could come back up here and plug 2 in here and 2 in there and check it. I plug 2 in there, that's 4 plus 6 is 10, and 2 times 5 is 10. That means e to the 10th would equal e to the 10th. And if you take the 3 in there, 3 squared is 9 plus 6 is 15, and 3 times 5 is 15. So I hope you see those give you the same answer so you can check those. Good luck on your homework, and I'll see you next time.